Welcome to the presentation of database transaction management. In the world of databases, managing transactions is crucial to ensuring that data remains accurate, consistent, and secure. This presentation will walk you through what a transaction is, the principles that govern reliable transaction, and the asset properties that help maintain data integrity even in the complex or concurrent environments. So, a transaction in a database management system is a sequence of one or more operations that are treated as a single logical unit of work. The operation could be involve reading, writing, or modifying data. The idea is that a transaction should be completed in a full. If any of the process fails, the entire transaction should be rolled back. This ensures the database remains consistent and prevents partial update or any errors. So the transaction is ruled from the ACID properties. So ACID stands for atomicity, consistency, isolation, and durability. So in short, atomicity is about all or nothing. We'll uh, deep dive this concept in the next slide one by one. But in short, atomicity is all or nothing, and consistency is all about the data correctness, meaning that the data has to stay correct before and after the operation. And for the isolation, transactions don't mess each other up. So every operations should be isolated from each other. And for the durability, it is about the durability of data, meaning once the data is saved, it stays saved even in the hardware or the network failure case. These all rules help databases stay reliable. So let's have a look for all of this principle one by one. So for the atomicity, this means that a transaction is like a single action, even if it has many steps. If one part of it doesn't work, the whole thing gets undone. For example, if you try to send money on your phone dies halfway, the transaction won't go through at all. It roll back so your money doesn't just disappear. So for if a person A transfers money to transfers B, if it is there's a error like hardware or network error. So if the money is withdrawn from the person A but it is not deposited to the person B, that won't be a accurate transaction. So what atomicity ensures us is that the operation should be done at all. If it is done like half, it should be rolled back, and all the transaction should be rolled back, and it should be from the step first. So no partial change are on the database. So for the consistency, it makes sure the database follows all the rules all the time. If the transaction tries to do something that breaks a rule, like putting a letter in a number field, it won't be allowed. The database always has to be in a correct state before and after transaction. The data must follow all integrity rules before and after a transaction. So for the isolation is all about keeping transactions from interfering with each other. If you and someone else are doing something at the same time, your transaction won't see each other half done work. It's like taking turns even if things are happening at the same time behind the scene. So for example, if there is a single product in e-commerce side, and if two users concurrently tries to save the product in the cart, then two users will have the same product in the cart. But that's not true because there will be a single product. So isolation ensures that the transactions are executed independently, right? So without interfering from each other's transaction. So by following the isolation logic, each of the user transactions or the operation will be isolated. So that makes the data accurate and the operations also accurate. So for the durability means that once the database says the transaction is complete, the change is permanent even if there are software or hardware failure like system crashes right after the operations. It's saved in a way that won't be lost. It's like kind of pressing save on a document after writing it, right? So if once the data is saved, then the data should be durable for like in a persistent way. By that way the customer data won't be lost at all. So this was all about managing transaction in database. So there are different type of transaction in different environment like distributed transactions and all, but this research is all about the transaction following the ACID properties. That's for atomicity, consistency, isolation, and durability. I hope you find it helpful. Thank you for listening. Bye bye then.